devices and as well as work holding devices. Okay, see here we have the various tool holding devices are there. So the namely the first one check, spindle, sleeve, socket, and as well as the work holding devices and other drilling operations and their uses we are going to see today's class. So first we will see one by one the tool holding devices. See, the first one is a drill chuck. So it is used to hold the straight shank drill. It is used to hold the straight shank drill. Okay, so it has a standard tapper shank, okay, which can be fitted into a tapper hole of a drill spindle. Okay, so that is about the drill chuck. So in figure we are able to see the drill chuck. So the jaws of the chuck are tightened around the drill by means of a drill chuck key. See here we are able to see the key. By using that key we can able to tighten the drill. Okay, so if you open and as well as close it. Okay, the jaws of the here we will see the jaws of tool holding. Okay, tool holding the drills. Here hold the tool by using this jaws. Okay, so that is about the drill chuck. So one of the major tool to hold the tool is drill chuck, and the next type is drilling machine spindle. Okay, drill machine spindle. So it has a more tapper. So the standard tapper shank drills are directly fitted into the spindle. So the standard tapper shank drill are directly fitted into the spindle. So the drills is removed by driving the drift. Okay, so if you want to remove the drill, so just figure just drive the drift. Okay, so from one side you can drive it, so it will open the drill. Okay, so that will be dropped down. So here the machine drill spindle you can able to see in the figure. And the next part is sleeve. So what is the purpose of sleeve? It is also one of the tool holding devices. So it is used to hold the tapper shank drills. Okay, so straight shanks. So the drills of the shank are mainly two types. One is a parallel shank, another one is a taper shank. So in order to hold the tapper shank drills, we use the sleeves. Okay, whose tapper is less than the tapper hole of the spindle. Okay, see the outside tapper of the sleeve matches with the spindle hole tapper. Okay, so once it matches, then we can use the sleeve. Okay, so here we are able to see the sleeve figure in the slide. So that is about the sleeve. And next sleeve, then socket. Okay, so sockets, it is used for drill whose tapper is larger than the spindle hole tapper. Okay, so it is a quite reverse to the sleeve. Okay, see opposite to the sleeve, so it is much longer than sleeve. Okay, its tapper shank conforms to the spindle hole tapper fits into it. Okay, so here we will see the figure in the socket. So here the socket are having the various parts. So the drill will be inserted into the socket. So the sleeve will be there and spindle is there. So here we use the drift. Okay, slot for inserting for the drift. So in the slot we insert the drift. Suppose if you want to remove this drill, just you can remove drive the drift. Automatically the drill will be dropped down. Here we will see the sockets. Socket figures. So those all are the tool holding device. So namely the tool holding devices are. So the first one is drill chuck. So drill chuck, spindle, sleeve and sockets. Okay, and then next we move to the other topic, that is the work holding devices. So work holding device. So the purpose of work holding device is used to hold the workpiece stationary. Okay, so in order to hold the workpiece stationary, so it used to hold the work correctly and rigidly during the drilling. Okay, so the following are the work holding devices will be used. So the first one is the drill vise. Okay, and second one is parallel bars, and third one is step block, and fourth one is angle plate, fifth one is V block, and sixth one is clamps and T-bolts, and seventh one is drill jigs. Okay, so these all are the various work holding devices. Okay, we will see one by one. So here we are able to see all work holding devices in one place. See here, this is a parallel bar. So it is a drill vise. The first one is drill vise. So the work is securely held in the drill vise. Okay, so it is fastened to the table by T-bolts. Okay, it is fastened by T-bolts. Okay, so that is a drill vise. So here the two jaws are there. So in between the jaws the work will be placed. Okay, so the work will be held stationary. Okay, so that is a drill vise. So here in the figure we are able to see here. So one is fixed jaw, another one is movable jaw. The movable jaw will be rotated by a handle. Okay, so conveniently we can able to set the different sizes of the work pieces. Okay, next one is parallel bars. So these are accurately machined, so used to raise the workpiece and stop damaging the vise and machine table. Okay, the main purpose of this parallel bars is used to raise the workpiece. Okay, so for small workpieces are there, the height will be low. So what happens, that will be goes at the bottom. Okay, so once the drilling machine cannot go and make the hole at the on the workpieces. Okay, to make conveniently, what happens, the workpiece will be move upside. Okay, how we are going to move up means, or rise means, by using a parallel bar. So at bottom end we can place the parallel bars. So the parallel bars are equally machined. Okay, so it is also set the work parallel to the base of the workpiece. Okay, so due to that, what happens, we are going to prevent the damage of vices. So that is the main concept of the parallel bars. So we will see the parallel bars in the figure, so above slide. And the next one is the step block. So it is used along with the clamps and as well as bolts. Okay, used to be along with the clamps and bolts. So it is used to provide support for the other end of the clamps. So here in the above figure also we will see the step blocks. Okay, so it is used to support the other end of the clamp. So one end of the clamp will be placed on the step block. Okay. So next, clamps and T-bolts. It is used to clamp the work to the table and avoid inaccuracy of the work accidents. Okay. So it should be arranged to grip near to the drilling. So free end of each clamp should be clamped. So that is about the clamps and T-bolts. Then last one is angle plate. So it has two faces with slots and as well as holes. So the work is attached to the one of its face. So in a figure we are able to see. And then next one is V blocks. So V blocks and U clamps are used to hold the round jobs. Okay, so if you want to make the drills on round jobs, so the parallel bars drill vise is not secure to hold stationary. Okay, so at that time, so we use the V blocks to hold the workpiece stationary. Okay, so the round jobs is used to hold the V blocks in U clamps. Okay, so there is V blocks. So then a drill jig. So it is locate and hold the work in proper position. Okay, so the purpose of drill jig is to locate and as well as locate and hold the work in a proper position. Okay, it guides the drills. So it is also used to guide the drills to get the hole in same exact location, all the parts, same and exact location at all the parts. Used in mass production. Generally these drill jigs will be used in mass production because it is a costlier. This is a drill jigs. Okay, so these all are the work holding devices. So the namely work holding devices, we have the various work holding devices. So let's see what are they. So work holding device. So there is a drill vise, parallel bars, step blocks, angle plates, V blocks, clamps and T-bolts, and drill jigs. These all are the various work holding devices used in drilling machines. Okay. So these are the today topics, that is tool holding devices and work holding devices. So tomorrow we will discuss the drilling operations. Okay, so thank you.